Hello, we are going to present our work PivoTAL, Prior-Driven Supervision for Weakly Supervised Temporal Action Localization. Weakly Supervised Temporal Action Localization is the task to localize actions using only video level labels. In our work, we introduce PivoTAL, which leverages multiple priors to generate pseudo-action snippets to localize actions directly in videos. This is unlike existing methods that learn to classify each video frame and perform post-training aggregation to generate the action snippets. By doing so, PivoTAL can achieve superior performance on the WTAL task, which can be seen in this example on the right, where existing methods lead to incomplete action snippets with high confident false positives, as shown in pink, while PivoTAL generates both complete and high confident true positive action snippets, as shown in blue. In weakly supervised temporal action localization, only video level action labels are available during training without any information about their temporal location. And the task is to localize actions using only this video level information. This makes the task challenging as no dense frame level labels are available on when the actions start and end. This is a useful setting as it helps to mitigate the need for expensive and labor-intensive dense annotations required by fully supervised temporal action localization. Existing methods attempt WTAL from a localization by classification perspective, where they learn to classify each video frame and only after training do aggregation into action snippets. Due to this, these methods have no explicit notion of temporal boundaries, as the post-training aggregation cannot influence training, and this leads to incomplete action snippets and several high-confident false positives. This can be observed in this long jump video where green denotes ground truth action snippets, blue denotes the true positives, and pink denotes false positive action snippets. Clearly, the existing WTAL leads to many false positive action snippets, that too with high confidence. To overcome these challenges, we introduce PivoTAL, which solves WTAL taking a localization by localization perspective, where it generates pseudo action snippets to learn to directly localize action snippets. And for that, PivoTAL leverages the newly introduced action snippet generation prior, action specific scene prior, and learnable Gaussian prior. This allows PivoTAL to produce high confident true positives, more complete action snippets, and low confident false positives. We can observe this in the same long jump video example, where compared to existing WTAL method, action snippets produced by PivoTAL are more complete and with higher confidence. For PivoTAL, we first take an existing WTAL approach, here referred to as base WTAL. Base WTAL decouples the per frame prediction into an actionness head, which predicts the probability for each frame being a foreground frame, and a classifier head, which predicts the probability of each action frame. Together, they generate the action prediction per frame. Notice that there is no explicit localization happening here. After training is complete, a snippet generator function operates as the post-training aggregation step to generate the final action snippet output in base WTAL. Since this happens post-training, the snippet generator has no influence on the model training in base WTAL. As part of PivoTAL, we use this base WTAL as a base WTAL head and use snippet generator not as a post-hoc operation but as an action snippet generation prior to obtain pseudo-action snippets to supervise direct localization. As can be seen in the enclosed orange box, output from the snippet generator becomes pseudo-action snippets, which provide supervision for direct localization to the prior-driven localization head of PivoTAL. This in turn also helps the snippet generator to influence training, unlike base WTAL.
PivoTAL introduces additional priors to improve the quality of pseudo-action snippets coming from the base WTAL. For the first prior, we utilize the fact that spatial information overlaps between action and no action video frames, making the background frames related to their neighboring foreground frames. In the example on the right, frames showing stadium in no action background frames hint that the action happening is that of cricket shot or cricket bowling. We introduce this in the form of an action-specific scene prior where the background MIL loss of base WTAL is modified such that for each background frame, the label is now a linear combination of the background class and the neighboring foreground action class. This prior improves the quality of the pseudo action snippets and thus improves overall localization. We further utilize the fact that per frame action prediction should exhibit a smooth trend over time, meaning that the predictions should be locally consistent at any point in the video. To enforce this as a prior into training, we introduce a learnable Gaussian prior which adds a Gaussian-based actionness head to generate a Gaussian mask and augment the actionness scores using the values locally sampled from the Gaussian mask. This further helps to improve the quality of pseudo-action snippets and thus the final localization performance. We conduct our experiments on the two standard action localization benchmarks of Thumos 14 and ActivityNet 1.3. We show that PivoTAL significantly outperforms all existing methods by at least 3% average MAP. Here, we qualitatively compare the predictions from PivoTAL with base WTAL. We can clearly observe that PivoTAL's predictions are significantly closer to the ground truth, with true positive action snippets being more complete and having higher confidence. To conclude, we introduce PivoTAL, a localization by localization method for WTAL that generates pseudo-action snippets to localize actions directly. To do so, PivoTAL introduces and leverages multiple priors, which include action snippet generation prior, action-specific scene prior, and learnable Gaussian prior. Through this approach, PivoTAL achieves at least 3% higher average MAP than any existing WTAL method on Thumos 14 and ActivityNet 1.3. With that, we hope to see you in person at our poster 228 in the PM session on Thursday, 22nd June. Thank you.